Hello friends, we discuss about network security. My topic is public key cryptography and RSA. Now we will discuss about the concept of public key cryptography. In a public key cryptography, we need a security. So we implement the algorithm named as RSA, and also we discuss about what are the possible attacks on RSA. See, first we discuss about public key cryptography. Public key cryptography, it's also known as a asymmetric key cryptography. That means pair of keys to be used. Each user has a pair of keys. One is a public key, another one is a private key. Public key is used for encryption. Is used at the sender side. It's also known as the public. And another one key is a private key, is used for decryption. It's used at the receiver side. It must be kept secret. It only known to the owner. So the key is called as a private key. Next, we discuss about the characteristics of public key. See, main characteristics of this algorithm use two keys. That keys are computationally infeasible. That is the security of the public key. To find the decryption key, knowing only by the algorithm and encryption key. And then second, it is easy to encrypt and decrypt message when your key is known. That time only it's easy. Never it is very infeasible to find by the attacker. Then either two related keys can be used for encryption, another one is used for the decryption. See, it is a public key cryptographic system. Now Bob send a message to the allies. Send a secured message. Bob want to send a secured message to allies. Now plain text as a input given by the Bob. Then Bob send a message with the allies public key from the key ring. Then it's encrypted by a allies public key. That encryption algorithm used by RSA. Now our original message is converted into the ciphertext. That means secured message to be transmitted. Then now in a receiver side, allies receive the ciphertext. The text is decrypted by the allies private key. That means allies own key. It must be kept secret. That key only known by allies. Then now allies decrypt the message using a RSA algorithm. That means it is the reverse of encryption algorithm. Now allies get a original message after decryption. That is the public key crypto system. Now let us discuss about algorithm. See, if you want to secure message, so implementing the algorithm, that algorithm name is RSA. R means reversed Samir Adelman. Three authors developed an algorithm of MIT, developed by MIT in 1977. It is one of the public key cryptographic system, best public key cryptographic system. It based on the exponential over integers model of prime. Then exponential takes this formula of operations order of log n3 and it uses a large integer number. Example 1024 bits. That calculation is done by factoring of large numbers. See how to key generated by RSA. Now user RSA determine two prime numbers at randomly. The two prime numbers are P and Q. Then select either E or D and compute each other. For example, E is used for the encryption key, D is used for the decryption key. Next calculation, prime P and Q with models calculation. That models is calculated by the factoring of two numbers P and Q. Multiplying these two numbers, we get the model value n. That means must be sufficiently large. And then it's typically guess and use probabilistic test. Then exponential to be calculated E and D. See how to key generated. Each user must be generate a pair of key private and public. In a sender side generate a public key, receiver side generate a private key. First you select two large prime numbers at random P and Q. Next you calculate the model value n is equal to P into Q. At that time note the factoring of multiplication value tau n is equal to P minus 1 into Q minus 1. Then that encryption value find out between the multiple factoring values where 1 less than E less than tau n. You find the greatest common divisor, then E comma tau n is equal to 1. So you get the encryption key value E. The same time you find the decryption key value D. Use this formula. T is equal to 1 mod 2n. So bubbly is the bubbly key encryption KU. KU means bubbly key using the encrypted key value N value. Then private key using a decrypted value and N value. See, it is the use of a RSA algorithm. Now encrypt a message M by the sender. So you first obtain a bubbly key. Recipient K is equal to E comma N. So we compute the value C is equal to M power E mod N. The next, to decrypt the ciphertext C by the owner, uses the private key. KR is equal to D comma N. So compute value M is equal to, M is the original message, C is a ciphertext. C power D mod N. In an encryption side, sender side use a encrypted key, then receiver side use a decrypted key. Note that the message M must be smaller than the modulus N. See how to RSA works. Using a Euler's theorem, you find the greatest common divisor value and calculate the N, 2n, and then carefully choose an E and D value. E is a bubbly key, it's also known as all. But D is a secret key, it only known by the user. See, it's an example. Now, you selected two prime number value as 17 and 11. So, n to be calculated, PQ. So, n is equal to 17 into 11. So, n value is calculated as 187. Tau n value to be calculated is 160. Using this formula, you choose E value as one of the prime multiple factor value is equal to 7. Then that same way decrypted value to be calculated. Now choose as decrypted key value as 23. So bubbly is the bubbly key KU is equal to 7, 187 and private key 23, 187. See, it's an example of RSA algorithm. Now plain text input value is 88 in a encryption by Bob with the alias bubbly key C is equal to M power E mod N formula. See, 88 is the input. Encrypted value, we choose the now encrypted value 7 mod 187 value is 11. This value is transmitted to the receiver side. This is called as a ciphertext. Secured message to be transmitted by decrypted side. Now decryption side using the decrypted value as 23. So 11, 23 mod 187 is equal to 88. So allies get a plain text after decryption. Using this formula C power D mod N. Then this time we have used the exponential value. Exponential value can use the square and multiplying algorithm. It is fast and efficient algorithm for exponentiation. For example, this concept is based on the squaring base. See, for example, 7 power 5 mod 11. How to easily calculate the exponential then? Based on the square value, we split up 7 power 4 mod 11 dot 7 power 1 mod 11. So you get the value 10 mod n. Easily calculated. How to easily calculate the exponential value by the user side. This is algorithm used for exponential calculation by the sender side. Then security. 3 approaches to attacking by RSA. 3 ways to attack this algorithm. One is the brute force key search. Brute force key search, that means all possible ways to find out the prime numbers. Then next one, mathematical attacks. Mathematical attacks means is used to calculate the prime factor of multiplication. Then timing attacks, it's based on running of a decryption algorithm. How to delay the running of decryption algorithm, that are attacked by the attacker. It is a security. 3 approaches for attacking a RSA. Now last conclusion. Now we have considered the principles of public key cryptography and implementing the RSA algorithm. Then what are the possible securities available in cryptography system? Thank you.